Drawing sunbeams on best dates. The ability to draw sunbeams accurately is extremely important, because only correctly drawn sunbeams can prove that a particular solar responsive design actually works. An accurate representation of sunbeams shows how the solar axis and shading design works as intended and is the best way to show the logic and validity of the solar responsive design. Many faulty solar responsive designs get built because the sunbeams were drawn incorrectly and therefore failed to raise a red flag. Best dates to study the sunbeams. A very important point in drawing meaningful sunbeams is picking the days and times that are best for testing and demonstrating the solar design. The most often chosen days, and unfortunately the worst choices, are June 21st and December 21st. The sun is highest in the sky on June 21st and therefore most easily shaded. Furthermore, June 21st does not represent the hottest time of the year, which occurs in July and August. Similarly, on December 21st the sun is lowest in the sky and is therefore least blocked by any overhang. And again, the coldest time of the year occurs in January and February and not around December 21st. To best understand the performance of a design, sunbeams should be drawn for the last day in the summer when it is still too hot and full shading is still desired, and for the last day in the winter when it is still too cold and full exposure to sunlight is still desired. These dates can be found for envelope-dominated buildings. These two sunbeams when drawn for 12 noon will reveal how much the south windows are shaded during the whole overheated period and how much sun they can collect during the whole underheated period. To fully understand the performance of east and west windows, also draw sunbeams at 9 a.m. and 3 p.m. on the last days of the overheated and underheated periods of the year. Notes: this table is for well-constructed, modern, envelope-dominated buildings. The overheated period occurs when average daily outdoor temperature is greater than 70 degrees Fahrenheit. The underheated period occurs when average daily outdoor temperature is under 60 degrees Fahrenheit. The climates shown are for the given reference cities. The climates at the boundaries are the average of the adjacent regions. Review: passive solar. Orientation is critical. Orient as much glazing as possible to the south or within 20 degrees of south. Use glazing on south windows with a high solar heat gain coefficient rather than a high R value. Use as much thermal mass as possible. A floor slab receiving direct solar radiation is best. Maximize the surface area of the mass rather than thickness. Use water or PCM for the most compact temperature storage. Use indoor night insulation, especially on south windows, to reduce both winter night heat loss and summer day heat gain whenever light and view are not needed. East, west, and north windows can use high-performance windows. Glazing must be fully shaded in the summer. Use a movable shading device on south windows to achieve 100% solar exposure in the winter and 100% shading in the summer. Make full use of the south facade for collecting the winter sun by using a combination of direct gain and trim wall. Trim walls must be shaded in the summer to prevent unnecessary heat gain. Use night insulation for trim walls. The combination of effective summer shading and winter night insulation makes it unnecessary to limit the amount of south glazing. Excess heat in solar heated spaces should be blown to non-solar heated spaces. Maximize south-facing glazing because south windows, 1. collect much more sun during the day than they lose at night, and 2. collect much more sun in the winter than in the summer. Passive solar heating consists essentially of south-facing glazing and thermal mass in a direct gain system. The more mass receiving direct or reflected solar radiation, the better. The mass should have a large surface area rather than depth. The three main passive solar systems are 1. Direct gain, 2. Trim wall thermosiphon, 3. Sun space greenhouse. Direct gain systems are the simplest and most economical but result in high light levels. Trim walls supply heat without light. Sun spaces are living spaces and solar heaters. To keep a sun space from being an energy liability, design it to be a semi-temperate living space. Passive systems must be shaded in summer to prevent an asset from becoming a liability. Passive solar is 80% orientation. Passive solar provides security against power outages and high energy prices. Some passive solar systems can be a free lunch because they can save money without the need to spend money. Passive solar is a vital strategy for sustainability.